Alright, hello everybody. I am Joshua Griffin, and today we're going over linked lists, adding and removing nodes and other things from the linked list. So, when you're looking at a linked list is normally depicted by nodes that look like squares, and they are pointing next to each other, but not back because this is a singled linked list. And so, this is what it would look like. Also, to note, in my last video, an overview of linked lists, I said that memory addresses were completely random. That's not completely true. They're called a hex. I believe it's a hexadecimal type, which is essentially 0 through 9 and A through F. Okay. So memory addresses will most commonly be 0 through 9 and A through F. So you can't have a Z, Q, P, like N in your memory address. That will never happen. So to correct myself, that was wrong, but it still stands that it would be just to you, it would be a random amount of numbers between those two increments. So adding and removing from linked lists. So a linked list, you have to remember each of these is pointing next to each other, and it has its address, right? So it's like a 0x FAB2, FAB2. It does, this is just an example. It doesn't need to be completely accurate. Now, if I wanted to insert something in, or if I wanted to add something in here, so for example, if I wanted to add it to this slot and I wanted to push this one down, what I have to do is first, I need to make a new node, which is right here, has the data and then the next value variable. This one needs to be updated to this here. So I'll just remake this really quick. Right? So now you have two next variables pointing to the same one. Now, the way you should do this is you should do this first, this one second. That way you never lose this address here, because if you do, this entire piece just becomes orphaned and you can't actually access that again. So that's how that would work. So I can do this again. So let's see. There. So we have three nodes. One's pointing at the other. We want to put one a new here. So new in here. My handwriting is god awful. I apologize. So we will be doing this effectively. This is new. So this is the normal. So number one, this needs to go here. So this is first. This is second. And then you remove this. So this next needs to equal that. This next needs to equal this. And this one doesn't even care about this. It doesn't need to know that it's even there. So that's the simple part of actually going through and inserting or adding in a new element. It's the same thing for the end. The end's actually probably one of the easiest ones, just because you have to just tack it on. So for example, since this is equal to null, instead of it being equal to null, when you add in a new one, so for example, we have a linked list of one data point, we want to make two, so we just add it on to the end. Instead of this equal to null, we actually take this, set it equal to a new data point, data, and then the next, and then we set this one equal to, and then this will be equal to that new address. If you don't understand that at first, watch it a few times, you will get it. It is a new concept to wrap your mind around. It took me a little bit. So that is inserting, adding into a new or a linked list. Removing. So removing is one of those functions that is also very easy. All you have to do is essentially say, I'm going to iterate through this, array of 4 linked lists, or 4 nodes for a linked list. Each of these has a next. Hopefully they all hold data. In your case, they should. You should never be adding nodes on that does not contain data. In this context, they all do. So here is an example of we want to remove this one. So remove, make that look like an R. So essentially we go through, we see this one, this is the one to be removed. We essentially say if the index is equal to this, so if I equals 1, because this is in the first position, this is 0, this is 1, 2, 3. Okay, there's 4, but this is at 1. So we say if I equals to 1, we take the previous next, this one, and instead of it being equal to this, we actually take it and we decide to say, okay, you're now equal to this node. And then we remove that. So I will just erase that real quick. So therefore, this is technically orphaned at this point, where you can then delete this. So you always want to make sure when you do this, when you remove this, you want to make sure that this is actually pointing to null. That way it doesn't delete this, which then will go and delete this one, and then which will go and delete whatever's next. Because what it does is it says, okay, I'm going to go through and delete one node. All right, this node has been deleted, but it had a next thing that was pointing to another block. Okay, well, I'm going to go delete that block too. And as you can see, that's going to end up creating a train of terrible things because it'll just go through and delete everything except for your first node. So that was something I ran into. Hopefully you guys don't, because I just showed you what will happen. So essentially that's how you would remove a node, and then you just delete it. So I can go through that again real quick. So we say next to this one, to this one, to this one, okay, and then we say, since we're removing this one, we want to go through this. We first say, okay, this is now equal to this next node instead of this one, right? So this is first, second, we point it to null, and third, we delete it. Okay, awesome. I hope this was helpful. Please let me know down in the comments how you guys liked it. I hope I can turn this to black later, but I want to do a special shout out to Dave Carrig. He helped me out here with a new drawing program. This is way better than what I was using before because the other one had an input lag, which was really. So that's essentially linked lists and adding and removing. In the next one, we'll go over the pros and cons between linked lists and vectors. There's a few of them. There's the reasons why you would use one versus the other. And in fact, you guys can actually, once you guys know this piece, you'll understand how to make a tree. So thank you guys very much for watching. And as always, like, comment, subscribe, and I'll see you later.